Today, the topic of discussion is on basic concept of refrigeration and air conditioning. That is Module 1, Part 2, PEME 601B. Myself, Dr. Suman Das, HOD, Department of Mechanical Engineering, Swami Vivekananda Institute of Science and Technology. In this chapter, we will discuss the concept of refrigeration and air conditioning, unit of refrigeration, refrigerant, desirable properties, and as well as the nomenclature. Now, refrigerator. A refrigerator is an equipment used to remove the heat continuously from the space. That space is called the sink. It maintains the temperature below the atmospheric temperature and reject the heat to the atmosphere, that is called source, by increasing the temperature potential of the heat to be rejected with the help of mechanical work input. Now the unit of refrigeration. The capacity of refrigeration unit is given in tons of refrigeration. So what is ton? A ton of refrigeration is defined as the quantity of heat to be removed in order to form 1 ton of ice in 24 hours when the initial temperature of the water is 0 degree centigrade. That means that convert 0 degree centigrade water into 0 degree centigrade ice, that is the quantity is 1 ton in 24 hours. That capacity is called the 1 ton of refrigeration. So 1 ton of refrigeration is nothing but that is 211 kilojoule per minute or 3.5167 kilowatt. Taking the latent heat of freezing of water is equal to 336 kilojoule per kg. That means we have to take the latent heat of freezing of water, that is 336 kilojoule per kg. Now simply we can write that 1 ton of refrigeration is nothing but 1000 into 336 by 24. So finally the value came, the value is coming, that is 14,000 kilojoule per hour or 3.8889 kilowatt. So 1 ton is nothing but 3.8889 kilowatt. Now already I have mentioned in my previous lecture, that is coefficient of performance. So that is simply known as COP. So the COP of a refrigeration system is a ratio of the heat removed, that is called cooling effect, produced from the system to the work supplied to achieve the heat removal. So COP is nothing but the heat removed per unit time divided by work supplied per unit time. So Q by W. So COP is nothing but that is 211 Tn by 60 P. So where P is the energy required and Tn is the capacity of the plant in terms of ton. And relative COP, that is the actual COP divided by theoretical COP. Now this is the heat engine diagram of heat engine and reversed heat engine. So already we know that heat engine is nothing but which convert heat energy into work. So the Q1 amount of heat is drawing from the source T1 and that is converting the device. That device is called the heat engine, and Q2 is rejected to the sink temperature T2 and the net work is W net. So this is the heat engine. That is the reversed heat engine means, so the heat is coming from that is the lower temperature reservoir that is maintained at T2 and going to the higher temperature reservoir that is maintained at temperature T1. So in that case the work is supplied on this device. So that means the refrigerator heat pump. So that is working on the reversed heat engine cycle. Now here, that is the simple the cyclic refrigeration plant. The cyclic refrigeration plant, that is, it is the block diagram. So compressor, condenser, expansion valve and evaporator. So the refrigerant is flowing through the compressor, after that condenser and expansion valve and evaporator. So this the right part is the flow chart of and block diagram of the vapor compression refrigeration plant unit. So COP is nothing but the desirable effect by work input. So desirable effect is, that is the Q2, that is the desirable effect. That means when Q2 amount of heat is going from the body temperature T2, so the T2 temperature will be maintained. If the Q2 amount of heat is rejected, is going out from the body at maintained at temperature T2. So body A. So desirable effect, that means Q2, and work input, that is W. So Q2 by W. So W is nothing but Q1 minus Q2. So the COP of refrigeration is nothing but Q2 by Q1 minus Q2. Similarly, cyclic heat pump. So heat pump, so what is heat pump? You can say that heat pump is generally used for a cold country where temperature of the atmosphere is very less compared to the room temperature, compared to the survival temperature. So the heat is coming out from the temperature, that means atmospheric temperature, and going, it is entering into the body temperature. So here the atmospheric temperature is less and body temperature is higher. So but heat is going from, it is coming from atmospheric temperature, that is maintained at T2, and going into the body temperature, that is maintained at T1. So here COP is nothing but the desired effect by work input. Here desired effect is Q1, that means we are maintaining the body temperature T1, and that is W is the work supplied or work input. So COP of heat pump is nothing but Q1 by Q1 minus Q2. Now Carnot heat engine and reversed Carnot heat engine shown in the block diagram. If you see the Carnot heat engine and reversed Carnot heat engine, so Carnot heat engine, heat is coming from the high temperature and entering into the lower temperature, that is Q1, that is the spontaneous process. And it is the reverse Carnot heat engine, it is going from, it is coming out from the lower temperature and entering into the higher temperature reservoir where some external work is supplied to achieve this. So this is a block diagram of Carnot heat engine and reverse Carnot heat engine. Now method of refrigeration, already I have mentioned in my previous lecture. So there are two methods in broad sense. One is the vapor compression refrigeration system, another one is the vapor absorption refrigeration system. So in the vapor compression refrigeration system, this is the flow diagram. So there are compressor, condenser, expansion valve and evaporator. There are four basic devices. So the refrigerant is flowing through this system, and the different parts, the uh, refrigerant are different, that means changes phase. So in the case of when refrigerant is entering into the compressor, that is cold refrigerant in form of vapor. When it is going out from the compressor, that is the hot refrigerant in the form of vapor. And when it is entering, when it is coming out from the condenser, that is the hot refrigerant, that is the subcooled liquid. And that subcooled liquid, through that through this device, that is the uh, before entering into the evaporator, that means through this expansion valve or throttle valve, that is in the cold refrigerant and boiling refrigerant, and also the cold refrigerant in the form of vapor. So when it entering into the evaporator, it absorbs heat from the evaporator and converted into the cold refrigerant in the form of vapor. So this is a cyclic process, and this is the refrigerant R22. So in this way it is working. So this is a vapor compression refrigeration system. Now the basic component, already I have mentioned these are the basic component, that is compressor, condenser, expansion valve or throttle valve and evaporator. Now what is compressor? Compressor is the heart of the refrigeration system. If you see the diagram, this is the black in color. The compressor acts as a pump that moves the refrigerant through the system. The temperature sensor starts the compressor action. So this is the diagram of the cross-sectional view of rotary compressor. And if you see the diagram, this is the rotary compressor and this is the suction, and after compression this is the discharge. So this is the suction inlet, suction line, and this is the inlet, and this is the discharge. Next one is the condenser. So what is condenser? So if you see the condenser that is generally visible in the backside of the refrigerator. The function of the condenser in a refrigeration system is to transfer heat from the refrigerant to another medium such as air or the water. By rejecting heat, the gaseous refrigerant condenses to liquid inside the condenser. So this is the condenser. If you see the condenser, so that means the heat is going out with the arrow. There is an arrow. So the with the help of the atmospheric air, the heat is going out to the atmosphere. So the condenser is looks like this. The type of condenser, the major type of condenser are that is the water cooled, air cooled, and as well as evaporative type. Now expansion valve or throttle valve. So what is the function of expansion valve and throttle valve? So if you see the expansion valve and throttle valve, the expansion valve removes pressure from the liquid refrigerant to allow expansion or charge of state from the liquid to vapor in a evaporator. The high pressure liquid refrigerant entering the expansion valve is white one. So this is the expansion valve or throttle valve. So that is the red in color, that is the entry level, and that is the blue color, that is the exit. So there is a sudden drop of pressure. That means that refrigerant is passing through a narrow passage. So due to the passing through the narrow passage, there is a sudden drop of pressure of the refrigerant. So this is the expansion valve and throttle valve diagram. So if you see the diagram, so this is the inlet of the refrigerant that is entering into three. So that refrigerant passing through a narrow passage, a narrow gap. So due to the passing of this refrigerant through a narrow gap, there is a sudden drop of pressure. And due to the sudden drop of pressure, the temperature will fall suddenly, and the refrigerant is converted into, that means due to sudden drop of temperature, so the refrigerant is that is very cold, converted to very cold, and that is going out, and that is entering into the evaporator. So this is the cross-sectional view of the uh, expansion valve or throttle valve. Now the capillary tube. The function of the capillary tube is same. The capillary tube will control the refrigerant flow by pressure drop across it in a refrigerant system. The diameter and length of the tube would determine the flow at a given pressure. So it would maintain evaporator pressure or the superheat. It does not have any moving parts, so that there is no wear out. So there is no moving part, that's why there is no wear and tear. So this is the picture of the capillary tube. Evaporator. Now the evaporator is located inside the refrigerator, and is the part of the part that makes the item in the refrigerator cold. So this is the diagram of the evaporator. If you see that, so and the refrigerant turns from the liquid into gas, that is red in color, liquid into gas through the evaporation. It cools the area around it. So when it is passing through this, so it cools around it, it absorbs heat from that, and finally it converted into the gaseous form and producing the proper environment for the storing the food. So this is the evaporator. This is the evaporator. And finally, this is the diagram of the evaporator, the cross-sectional view. And if you see the diagram, that is the inside the evaporator, and this is the originally cross-section, that means inside what is the evaporator, that is shown in this diagram. Okay, so thank you very much.